Everyone can hear me. So this is a truly great opportunity for all of us to get together. Also, we are going through such a turbulent time. So thank you, first of all, Dr. Paliwal and Dr. Thakur for giving me this opportunity to be part of this uh, interesting event, which is focused on Internet of Things or IoT. And that's one topic that is very near and dear to my heart, and we will learn very shortly why it is. So I'm going to try to keep this presentation short so that we can have some time and spend some quality time discussing various aspects or Q&As that you might have. So first of all, just to give you introduction, how I got involved from mechanical engineering and nuclear engineering and energy systems to sensors and the world of IoT and IIoT and cybersecurity. So it's a dream come true for a Nobel laureate and a very interesting story. We'll start with that. We'll then talk about IoT and IIoT. So IoT, as you know, is Internet of Things, and Industrial Internet of Things is IIoT. And there is a lot of similarities, but there are some key differences and distinctions that we need to understand. And then we'll talk about the risk-informed threat modeling approach. How can we understand how cybersecurity and various threat vectors can impact your IoT or IIoT infrastructure? How to take care of those? And then we will actually do something fun. I would give you a demo of a real hack or a cyber attack. It's not really real, it's a simulated attack on a PLC. And we'll show you how the bad guys or bad actors could actually gain access to some critical pieces of your infrastructure and could mess with something. And at the end, we will talk about some lessons on cybersecurity, and there are some interesting lessons from Ramayana. We'll see how that is related. And then social distancing that everybody is practicing nowadays also teaches us something about IIoT security. Specifically, we'll talk about the air gap, and then we'll conclude the session and open the floor to Q&As. In case somebody has an urge to ask questions in between, feel free to do so. I am not sure the audio would permit us to do that seamlessly, but we'll try our best. So this is how my journey started. So it's about 20 years ago that I was taking this seminar with my thesis advisor, Professor Mario Molina, who happens to be a Nobel laureate for finding in '99 for finding the root cause of the ozone hole, and we were discussing about a project on Mexico City air quality, the mathematical modeling of the point sources of air emissions. And the key challenge of any mathematical model that probably all of you who are involved in some modeling or other is how do you validate a model? So any model without proper validation is pretty much garbage in and garbage out, has not much meaning and value other than a good intellectual exercise. So he was lamenting that he wished that he had lots of sensors connected all over the place so that when the Gaussian air pollutant dispersion model forms, he could actually collect the data of air pollution or pollutant dispersion at various points or various points in the trajectory and to validate their mathematical model. So that is where my journey. thinking about how critical and important sensors are, but I had never dreamt that in his lifetime it would become possible to actually have sensors spread all across, and you could easily validate those fancy mathematical models. And you see that today. Here are some examples of IoT enabled air quality monitors, which would actually tell you all the pollutant concentrations at a given point of time and would continue to report those values to you through their connectivity using 4G LTE technology. And so that dream has now been realized. So that's the pretext of how I got into this very interesting field. But the moment you talk about sensors, connectivity, internet, one of the key thing that you come across very quickly is cybersecurity, because it has become much easier than it was ever before for anybody sitting in a basement to initiate a cyber attack on the most advanced and sophisticated infrastructure that could be out there in the world. It could be power plants, it could be manufacturing units, it could be chemical industry. Therefore, as the prevalence of IoT and IIoT or connected devices is increasing, the cybersecurity is becoming very, very important. So when I saw the proposed agenda and discussed with Dr. Thakur, she kindly agreed to include this very important topic as part of these deliberations. So thank you for that. So the key technology trends which are driving IoT and IIoT. So the key technology trends that are driving this adoption are there are lots and lots of connected devices which are generating tons of data. Question is, how do we handle? What do we derive? How do we gain insight from that data? 20 years ago, 30 years ago, even if we had that data, we did not have the capability to be able to leverage that data to gain insight from that data. With advancement in computational capability, the cloud computing, it is now possible for us to ingest all this data and derive meaningful conclusions and insights from that data. So these are some of the trends that our ability to perform analytics on large quantity, large volume of data, ability to use artificial intelligence to decipher this data and make sense of it and predictions for use of advancement of our generations. That means more and more devices are going to continue to come online. And as these devices become connected and continue to generate all this data, keeping these devices safe and secure is becoming more important. So let's address this question. What is the key difference between IoT and IIoT? And my interest is more on the industrial IoT side of things because I work with Siemens as their distribution partner on their SCADA and automation and control systems. So IIoT has been more of an area of my interest because that touches upon critical infrastructure that we all rely upon, for example, power plants, chemical plants, manufacturing units. So any device that is connected to the internet, you call it IoT device or Internet of Things, which could be an actuator, it could be collecting some data, could be performing some meaningful work for you. All these smart devices that we talk about, data, microwave, Fitbit, then you name it, basically. Anything could be connected to internet today and could be an IoT device. Now, industrial IoT devices, on the other hand, serve some special purpose in the area of manufacturing, medical field, to aid military, in the aviation, and so on. Specifically, those could be the things that traditionally have been forte of the industrial control systems on the plant floor. For example, power meters, condition monitoring sensors, automation controls, and so on. Here are some examples of IoT and IIoT security that have been simulated by the researchers, also been perpetrated by the bad guys. Some IoT examples are the surveillance camera hijacking, where some bad actors were able to actually hijack a large number of surveillance cameras which were unsecured and use them to create a denial of service attack on some of the critical cloud server infrastructure, especially on the DNS servers around the world. Medical devices, for example, are nowadays being connected. My wife uses one for monitoring of her blood sugar on a daily basis. These devices now connect wirelessly either to your phone or directly to the internet. If these devices are manipulated, the readings could potentially jeopardize human health. And there have been several researchers who have been able to demonstrate that they can hack into cars, they can manipulate the brakes, engines, and many other critical parts of the automobile. Industrial IoT examples, for example, from cybersecurity perspective, the most famous that everybody has heard of is called Stuxnet. Although the malware started by a USB within the Iranian centrifuge system, it's a nuclear enrichment facility, but it perpetrated through the network. Ukrainian power grid is a true IIoT cybersecurity hacking example where the bad guys used malwares to get into the power grid's network and were able to manipulate the grid to disrupt the supply to the whole Ukrainian state. Saudi oil fields have constantly faced threat from especially some of the Siemens devices, industrial control systems hacked into their satellite communications of the Australian government have been hacked by cybersecurity. German steel mills have reported similar attacks on their system. Google's building management system in Australia was by some cyber researchers. They were doing some research on the ICS systems or the building management and control systems, and they found that they could pretty much control not only the temperature and humidity, but also security alarm system of the building. So what are the key differences in IoT and IIoT? While IoT mostly focuses on the consumer application, which relatively are low security, high cyber breach potential because of the low security, but the impact is low to medium, and there's a moderate risk profile of the. Whereas when we talk about the IIoT or industrial IoT devices, these are used in manufacturing facility, military, healthcare, aviation, and so on. And the spectrum of the security is pretty broad from low to medium to very high, depending upon what is the nature of the device and what is the function that it is serving. Medium cyber breach potential generally exists, or certain cases have been observed where state actors or state-sponsored actors were involved, then a very high cyber breach potential has also been observed. There's medium to high impact, and there is moderate to very high risk if something goes wrong. Imagine somebody could manipulate your power plant and change the temperature, pressure, or other variables which are important. This could be not only a conventional power plant, but could be a nuclear power plant where some manipulation of parameters could result in an accident, loss of coolant accident, or loss of power expenditure, LOCA or LOPA. So the, so the key thing is that we understand that IoT is not equal to IIoT. So there may be small intersection where it is very gray area where IoT devices are IIoT devices. Priyanka, could you please mute? Please? Thank you. So again, the main point is that IoT devices are not necessarily equal to IoT. So the key difference is that in the IIoT devices, we are connecting to the operations technology. That essentially means industrial control system or ICS. On the one hand, we have the devices which are very short asset life cycle, but IoT devices are typically power plants could be generators, could have very long asset cycle. And these assets are much more expensive than the traditional consumer. The protocols that typically used for the standard IoT could range from TCP/IP to USB and so on, Bluetooth. Where for IIoT devices, we are talking about a very broad industrial control protocol. And these could be, for example, Profinet, Modbus, DMP3, and many other similar protocols adopted in the industrial control systems. Typically, the ICS systems have legacy infrastructure. That means changing those systems is not very easy, and only you could adopt some edge devices that would make your traditional infrastructure into an IoT capable or industrial IoT device. Safety and reliability and confidentiality and integrity is very important in any system where there is data flow. But when it comes to industry, safety and reliability come first, and confidentiality and integrity takes backseat. Because even if we lose some production data, it is not potentially going to harm the operations or will not cause any health hazard for the operators. Incidents consequences are very different on IoT side, although now it's very pervasive, but on IIoT side, there can be not only loss of data, but could be potential loss of life, which is very serious and is taken very seriously in the industrial safety and reliability perspective. Another thing is for IoT devices, you could actively scan the devices because even if you crash a device, potentially it's not going to cause a serious harm. Whereas in case of an industrial control system, you cannot actively ping the devices, actively scan the devices. Additionally, patch management is also not so easy for IIoT devices. For example, if your home camera, which is doing surveillance, if it is off for 2 minutes when you need to update it, it's no problem. You can install the latest version of the firmware and you can restart it. You will lose 2 minutes of recording. Whereas if this was an industrial control system, which is controlling 24/7 critical production infrastructure, you cannot just initiate a firmware update in the middle of the production cycle. It could potentially cause millions of dollars of loss or a complete batch being ruined because of the restart of the device. So patch management is much more difficult, and that's why the security holes potentially can remain unplugged in the industrial devices for a long time. So why should people care about IoT or IIoT and cybersecurity? One, when it comes to industrial security, safety of personnel and product is very, very important. Second, if there is an incident, it could potentially lead to environmental hazards, and we all know the sad incidents of the leak of the isocyanide methyl gas in Bhopal incident. So there are severe consequences of environmental consequences of malfunctioning of ICS or industrial IoT devices. And it's a bad business because companies do not want to be in news for the wrong reason that their systems were breached or hacked. Uptime and productivity is very important to make sure that manufacturing units meet their customer demands, quality, and reliability for their suppliers and customers. So they do not want their systems to be shut down for prolonged duration because of the cybersecurity. Another important thing is confidentiality of data, protection of intellectual property is also important. You would not want that to be hacked. So what is happening is as we move through this industrialization, now we call it Industry 4.0, which is result of the age of digitalization. So we are generating huge amount of data, which now you call it big data. But key important thing is that you want to make sure that your OEE and KPI, which is operational efficiency and the key performance indicators, are constantly measured, monitored, and reported. Now, previously, you had all this data somewhat isolated on an island. Now we are able to connect this data through devices directly to the cloud so that you can derive meaningful insights from this data in a much more efficient way than it was possible before. You can perform analytics, you can take corrective action before it's too late. At the same time, as you connected these islands of production from the plant floor to internet, that means you have increased the attack surface tremendously, which means you have opened up yourself to potentially more attacks, more cyber attacks. So the top three threats for the industrial control system from IIoT perspective are social engineering and phishing. That has known to be a common attack vector that has been used to penetrate some of these manufacturing and production facilities. So Ukrainian power grid is a perfect example where social engineering and phishing was used to hack into the power grid. Malware via removable media through a USB Stuxnet virus was introduced to the Iranian nuclear enrichment facility and which caused havoc to them. Similarly, malware has been introduced via water hole technique through internet and intranet, and one example of that is a malware called as Hevex, which targeted European and American aviation and energy sector 3-4 years ago. So from industry's perspective, their key priorities are how do they manage risk. So the safety, security, brand, and intellectual property. These are the 4 key parameters that they care about most. Improving quality for their products and services are another important parameter for which the large amount of data that is being collected and reported and is being analyzed through IIoT systems is another priority. And third most important is compliance. They do collect a lot of data that helps them meet regulatory and compliance requirements along with meeting the industry standards. So the drivers of big data, which is making this convergence of the OT systems and the IT systems, eventually resulting into what is called as IIoT, are big data and analytics, real-time monitoring and diagnostic capability, remote control and management capability, where previously that was not possible. So to secure IT and OT resources, you have networks to worry about, you have devices and hardware to worry about, and the third layer is the software. These three things you have to pay attention to. And through this, you basically address this pentagon of things where confidentiality is important, availability is important for you, reliability is important, and integrity of the data is important for you in any industrial control systems. So now we will briefly look at anatomy of a PLC hack. So some of those who have worked in any of manufacturing facility or are familiar with the programmable logic control systems, these are the key elements that make any industrial control and industrial automation and control systems. So what is typically done is the hackers would identify a target. Now, you would wonder why would a PLC be connected to the internet? But believe it or not, there are tons of such devices that are connected to the internet and then open, available for bad actors to hack into. They would enumerate and identify the active, and the third step would be to rewrite register and coil values. Those are registers are nothing but the memory space where key parameters for the production process are being stored. Now, if those values are changed, that means your production process is going to behave completely differently, and it could result in a catastrophic failure of the system or an accident. So, you would wonder why and how could I get access to such system? If you go to a search engine such as SHODAN, SHODAN, you can easily see that they have categorized lots of industrial control systems, databases, and cameras that are available out in the wild. And you can identify these devices by their manufacturer, by what kind of functions they perform, what is their model number, and so on. Not only that, their public IP addresses are also available. That means if bad actor wanted to cause severe harm, they could use this public IP address to potentially identify the geographic location of this device and could harm a particular plant or target an attack on a particular plant located in a geographic region. So this is an example how a PLC hack. So this was done in our lab by one of our engineer, Mike Kerno, and we have created this so it could be demonstrated how easy it is for a bad actor to identify a PLC on the network and then do the hacking. So the steps would show up on the screen, and it's a little hard to see the text, but on the right in the small panes, what you see is values that are being stored in the PLC registers and how those values are now through this hack being manipulated and changed. A copy of this presentation along with this simulation will be available through Dr. Paliwal and Dr. Thakur. Feel free to take a closer look at that, and if you have any questions, let us know. So basically, first of all, you would identify which functions are enabled on the target PLC. So here we have used a homegrown tool called Rapid Fire. Then you find that what are the holding registers which are available for you to read and write, which store certain values in the PLC. So those values are shown in the right? Now the coils are readable and writable. So very fascinating to see. So now you will see that how we hack into this PLC and manipulate the address spaces and register values to some random arbitrary values. So you see that initially there are some values written on these register in the top right corner. Now we will change those, manipulate those values. You can see that all these values have been. So this, no fancy tools were required. This is perfect example of a PLC that was up and available in the wild, and anybody could go in and manipulate that. Imagine that this was controlling a power plant or controlling a manufacturing facility in your town. You would be very scared to know that something like this is open for bad guys to easily manipulate and hack into. So this is the demo or a simulation of the PLC hack. Let us go to the next. So some lessons that we learned from this were: one, if you have such a sensitive device, then learn from the COVID pandemic. Social distancing is a good idea. Don't let these two things, cloud and your device, talk to each other. Keep the distance maintained. Second lesson we learned from that is, if you need to connect this device to the cloud, then make sure that necessary protection are in place. An example is mask today. Here it would be a firewall, for example, that would manage and control bidirectional traffic between your PLC and the cloud. Now, that was a very simplistic model of risk. If we are concerned about more sophisticated environment and want to create a more detailed risk map and perform a risk analysis, then we could devise various functions into low risk, medium risk, and high risk, and accordingly we could come up with appropriate solutions. For example, a low risk device could be connected through a simple firewall that is equivalent to your simple 3-layer surgical mask. A medium risk device, then you would require it to have segmentation of the network so that traffic can be filtered and can be appropriately routed to the right device without having the ability to hack into your system. So here, if there are medium risk devices, then you would use, for example, your N95 mask. If you have a system with very high risk, for example, a power plant or a nuclear installation or a military installation, then you would absolutely be very, very careful. That is like dealing with COVID patients in the emergency ward. So you would deploy all the protective gear that you have access to. And the most common of those devices that are available to us today are called unidirectional gateways or data diodes. What does that mean is you would be able to get the data out for monitoring purposes, but you cannot control the device from your mobile phone while you're waiting on a traffic light or hanging out in a gym or in a bar with friends, and you are not being able to then control the power plant, for example. But you can still monitor the device. This unidirectional gateway would allow you to get access to all that data that is critical for you to view and gain insight into it. And if needed, then call back to the power plant or your facility and request an operator to take appropriate action. So the building blocks of the industrial IoT cybersecurity are essentially these 3 P's: people, practice, policies, and procedures. So train your people, develop the culture of security, make sure that access control is given to the right people for the right kind of functionality. An operator who's not trained in doing critical functions should, for example, not be given access to perform those operations or be able to do override. Practice is very important. Cyber hygiene, practicing making sure that the network is properly segmented and defense in depth practice is deployed in your IT as well as OT networks. Uh, Zones and conduits are created to route appropriate traffic to various devices without giving free rein to everybody in a flat network. And security and encryption of the data is ensured. Another very important thing is policies and procedures. Make sure that all the access data is audited periodically and you keep inventory of the logs so you can check if there are any abnormal activities going on your IT or OT network so you could detect those in a timely fashion and respond to that. And most important thing is change control process. Most of the time when people bring in a new device to the network, they forget to remove the old device, which could then become a pivot or an entry point for bad guys to get into your network. So why do we actually use IIoT in industrial facilities or manufacturing power plants? So two key reasons. One, you want to be able to monitor things remotely. An operator may be sitting in the plant, but a manager may want to get data or access to the information in real time. So you could do that with help from the firewalls, proper segmentation, data diodes, or data collection units, or in very, very sensitive facilities, you could deploy what is called as unidirectional gateways. So on the one hand, the firewalls allow bidirectional traffic, means the data can go inside to perform control functions, and data can also go out to give you information about performance of the plant, allow you to perform analytics, whereas data going in would allow you to control those plant functions, for example, changing the temperature, RPM of certain devices that are on your network. A data diode, on the other hand, or data collection unit, would simply allow you to collect this data and pass it on. Similarly, unidirectional gateway go a step further and they do not have physical capability to send data back in. That means data can only flow from one direction to another direction. Physically, they typically in a router or a gateway, you would have a transmission function and a receiving function. So they are either in a transmission mode, means the second mode of fiber is completely absent by design in these devices, making it very, very, very secure. So another function that you need access to these IIoT or manufacturing facilities is because you wanted to perform remote diagnosis and control. For example, if something goes wrong and there is an expert, let's say there's a turbine that you are monitoring and there's abnormal excessive vibration of the turbine, you cannot have an expert show up on your plant in your plant instantly. So you could then take advantage of remote diagnosis capability if you are submitting that data. For example, in Atlanta, in United States, GE has a big data center where they basically collect data for more than 250 power plants from across 60 countries in the world. And what it allows them to do is this data allows them to diagnose and be able to take proactive measures if they detect that there is a potential failure, impending failure of a device in a power plant. They can reach out to the plant operator and can request a planned maintenance window instead of a complete shutdown of the plant. They could then plan it and use it accordingly. There are some other similar tools. One could be operator assisted access can be done, and telecontrol server is another uh, interesting tool that allows you remote access without having to have access all the time, secure access. It's a multiple companies have. Cinema RC is name of the tool that Siemens has, telecontrol server, and Microsoft has come up with an augmented reality tool that allows you to perform these control or maintenance functions on site with help of augmented reality. And there's a small video. I do not know through this WebEx would you be able to see, but let's give it a shot.
Samudra, we are able to see, but the voice is not coming. The video voice is not coming.
So remote devices. This is complex that the government can be able to guide. So that was just one example of how augmented reality can help you perform these operations. Now there are these two model diagrams that my team, especially Balu Subramani, he's cybersecurity lead on our team, has put together to help uh, manufacturing units come up with a network map that would be secure and would also allow remote access without potential for compromise. So an interesting component here is the key that you see on the top. This is actually a physical key. What it means is that the network is segmented and no bad actor actually can get into the network until an operator inside physically turns on the key, which basically there's a breaker and that allows the key switch to operate and close the breaker and give the access to the facilities OT network. So there are two networks here. On the left, what you see is called as Operation Technology Network, and on the right, you see what is called as IT network. And a remote operator, if they need help, would need somebody inside the plant to physically turn on the key and make it possible for the remote operator to log into the system and see. Once that work is done, this key can again be turned off and the connection can be again disconnected securely so that there is zero or no possibility of any unauthorized access. So the common attack vectors are, malwares, malicious code, denial of service, distributed denial of service, or industrial espionage, which we saw in the case of Iranian nuclear plant. So now we'll just go back to our roots. So what are the key lessons that Ramayana has to teach us about cybersecurity? So we talked about IoT, we talked about industrial control systems or IIoT, and then we talked about what are the most common vectors, threat vectors that are deployed by the bad actors to gain access to the IoT devices or IIoT devices. So let us see how those lessons come into play, and you probably would all be able to relate to these the lessons from Ramayana. So this clearly tells you that a firewall is not enough to protect your IoT or IIoT devices. Although Lakshman did a very good job of trying to keep Sitaji secure by drawing Lakshman Rekha, which is the firewall equivalent today. But that's obviously not enough to keep our assets secure. So second lesson is beware of phishing and social engineering. So you see that Marich, this is perfect example how social engineering was deployed in that time to draw Sitaji out of the firewall. And this happens commonly with most of us when we get a very interesting link. Somebody says, click on this and you will get 5,000 rupees or dollars or something, or you have won a prize. And that is what they are trying to do. They are inviting you or encouraging you to come out of that firewall, click on that link, and fall prey to that marriage. So beware of the phishing and social engineering. And third, the most important lesson is that every device on the network, be it IoT or IIoT, needs to be authenticated, recognized, and listed so that only the devices that have proper authentication and identification can talk to the other devices on the network. How that was done in Ramayan time? So you see that when Hanumanji went to the Vatika in Lanka, so he had to present his identity, which was in form of the ring that Sri Ram gave him. So once his identity was proven, only then she trusted that yes, this guy is legitimate and she can. So there are several lessons we can learn from all around and be careful about, not only in your daily IT activities in life, but can also be deployed in thinking about large, complex industrial systems, IoT networks, and IIoT networks. So, how do we ensure IIoT or industrial control systems cyber security? The first and foremost thing is access levels and controls should be very well defined and made sure that only the minimal level of access required to perform a task is given to a person. SSL encryption or a TLS encryption is very important so that man in the middle attack does not happen. And you can show that the data integrity is retained when the data, for example, if a command to increase RPM of a turbine goes from the controller, you want to make sure that it goes in the appropriate quantity, not that it's manipulated by somebody in the middle. Fuzz and penetration testing are some techniques that are used to make sure that the systems do not respond in an unexpected manner when random data is thrown at those systems, because it could result in catastrophic failure if the system response is such that it completely fails to do its job. The risk assessment based segmentation and zoning of various parts of your total system is very important so that you can ensure that you need a basic three-layer mask, you need an N95, or you need a complete protective PPE gear, right? Firewalls and DMZs are very helpful in trying to keep these bad actors out. However, remember the Ramayana example? Firewall is good, but not enough to keep the bad guys out. For very high risk environments, what you need is unidirectional gateways and data diodes that would allow data to flow only from inside to out. We could do all these things and keep the bad guys out. What about the bad guys inside the organization? So you have to think about those as well. The bad actors within your organization could bring in a USB, which is laden with malware and could cause havoc within your system. So, concluding remarks, every connected device, be it IoT or IIoT, is hackable because for every 1,000 lines of code, there are at least 40 bugs that are out there based on the data that is available on software design and development. So every device with appropriate amount of time, energy, and resources can be hacked. So make sure to practice cyber hygiene when you're deploying the IoT or IIoT network. Second important thing is that a lot of these devices, when they are being designed, nobody thinks about security. Security comes as an afterthought. So security has to be taken into account at the time of design, not as an afterthought. So that common passwords are passwords. That's not how these devices should go out in the field. Third thing, air gap, which is a very common and interesting concept which keeps your operation technology network separate from your IT network physically. But think about it. You cannot keep this critical data that you are generating on your plant floor isolated because that data is important for your management, for your production team to determine how your production facility is performing. What is your OEE? What are your KPIs? Are you meeting those metrics or not? Or are you able to make some changes to your systems to improve performance or efficiency of the system? To do that, you have to connect your OT systems to the IT systems to be able to collect that data. So, air gap, although a noble principle, no longer exists anywhere except some very old, maybe 60, 100-year-old factories. Hope and pray is not strategy, planned, design, think, review, implement, and execute. You can start by doing a simple asset audit of your IoT as well as the what are IP addresses. Simple enumeration using a net scanner would allow you to see what are the devices on your network. You could then do port scan to identify which ports are open, what are the vulnerabilities that exist in your network. Then you could decide whether you should take any action or not. Perform a risk assessment of your IoT and IIoT network and divide these assets into low, medium, high, and very high risk categories, and then create appropriate DMZs, firewalls, or network segments so that every segment of your network can be appropriately covered depending upon what is the risk profile of that segment. Make sure to put some configuration and change control process in place. No new devices on your network should be added without ensuring that the firmware is up to date. There are no vulnerabilities that are reported and exist. Stay cyberfit with cyber workouts. So cyber workouts is a term that was coined by one of my colleagues, Balu Subramani. And basically, these are small, simple exercises that you could take within your organization to make sure that you're doing all that is needed to keep your IoT and IIoT network safe. Some of the resources ICS Cert is a very good resource for you to keep updated on what are the current vulnerabilities that exist in various ICS and IIoT networks out there. NIST 882 standards and ISO 62443 standards are very good basic principles to follow when designing and deploying a new IIoT or IoT network. So, last but not the least, I would like to thank Dr. Paliwal and Dr. Thakur for giving me this opportunity, and to our colleagues who are not here time, Mike, our cybersecurity and Alu Subramani's cybersecurity, and Anna Preta for senior helped me prepare this presentation. Thank you. So if you have questions, feel free to.
Thank you very much, Samudra, for such an interesting talk. There are in the chat box, there is some question for you.
Oh, okay, let me.
मेरी जिंदगी का सबसे हसीन पल भी तुम हो, मेरी हर मुश्किल का हाल भी तुम हो, मैं कभी
Okay, let me go.
Or otherwise, I can read.
Let me try. I'll see if these are all good. Yes.
I can read. There is only one question, I think.
Okay.
I can read that. Yeah.
Go ahead.
Yeah. That the question is, what is basic difference between IoT and IIoT due to disturbance, even the full form not got properly?
Oh, okay. So IoT.
He is asking about the difference.
Right. So IoT is Internet of Things, which is basically any device or gadget that is connected through Bluetooth, through Wi-Fi, 4G, LTE. And IIoT is nothing but industrial devices that are connected to some a turbine connected to the internet and reporting performance data. That would be IIoT.
Yeah.
A copy of the slides have been provided to Dr. Thakur and Dr. Paliwal. Feel free to take a look at that. It has more details about the difference.
Yeah. And Dr. Samud, there is one more question. What would be the right and effective method to prevent such attacks? Security at hardware level or software-based approach?
So basically, first of all, we all have to understand this single approach. That's all. There's no, depending upon the risk profile, you would have to adopt either a combination of software and hardware or a hardware-based approach. For example, if I have a very sensitive nuclear power plant, I cannot put any risk on power plant's meltdown because of such an activity. I would deploy a unidirectional gateway as hardware. Again, when it comes to unidirectional gateway, just the hardware is not enough. It ensures that the data is being replicated correctly from inside the device. Always would be a combination.
And another question is, can you kindly suggest few device or methods for low risk?
Start with a firewall, FortiGate 60E or device. Another one would be a system IoT firewall, industrial grade firewall. Those are the most cost effective devices to start to protect your network. On the high end, there is a called waterfall, which makes of unidirectional gateway. So to protect in such sensitive installation, you would look to using unidirectional gateways. There are data diodes that I see this you could use those.
Another one is how in these days diodes are used for monitoring the network. That was the question. Are we still using diodes for monitoring the network?
So that's a data diode which uses just the term diode to indicate that data flows only from one direction to another. So that
Okay.
means somebody can actually get in, send the data only in one direction. It's not really a diode, but name of the device is.
Okay. And then one person is asking that I understand that firewall is for medium risk while data diodes are for high risk. For example, for low risk arrest. So he's just asking about the firewall is used for medium risk while data diodes are for the high risk.
I would say firewall for low risk. Firewall, you have to have a basic firewall, advanced next generation firewall, medium risk, and medium risk deploy firewall as well as data type. For very high risk, you need special gateway.
So another one is also asking about the more explanation about the data diode.
Okay. Let us say, hopefully, if you have some networking background, that will be easier for you to follow this. I think firewall allows a rule in the firewall allows traffic to go from LAN to WAN, and it prohibits